out for my dreams, I reached out for my vision, I reached out for help that I thought I needed. Cause reaching out is the proof of passion.
Hello again, our most valued student. My name is Confident. Welcome to our lesson today, where we are going to look at the logarithm equations. Now, we have looked previously at the laws of logarithms. We looked at the introduction to those laws, and we had some examples on how you can use the laws to your advantage. You can check those lessons. But today we are looking at the laws, at the logarithmic equations. In other words, we're going to solve equations involving the laws of logarithms. Now, the first thing that we're given, or the first thing that I'll need you to remember whenever we are solving equations involving laws is, suppose you are given, it's not a law as such, but suppose you are given log base a of x is equal to a b. Now, that is an example of an equation involving logarithm. So now, what I want you to remember is you can write this as an expression to say this is same as x is equal to, that is the x, is equal to a, the base becomes the number here. In other words, it is the base of the exponent, if I can write it properly, is same as a. Remember, a is the base. Now if we turn it back into exponents, it's the base of b. So x is equal to a to the power of b. That's how you can simplify the given equation. So the first thing you must remember is you must only have a combined part whereby it's a log with a base and an x and then equal to a b. So if they, for example, they say log base x is equal to a b. Now what you must remember is hidden is a base 10. If they don't put any base, you must always know it's a base 10. So this can then become x is equal to 10 to the power of b. Now using that same method we've been given, you can simply say that in this case our a here is represented by the x, and our x here is represented by the 4, and our b is represented by 2. So if this simplifies to x, so we take our 4 is equal to x to the power of 2. So that's how we start with the laws of logarithms. Now the next thing that you must continue is to simplify. So here it says 4 is equal to x squared. There are two ways that I'm going to show you here, but you can continue with the exponential way of solving it. What is 4? 4 is same as 2 to the power of 2 is equal to x squared. Now if you remember previously we looked at the equations involving exponents. If the powers are the same, you can see this is power 2, this is power 2. Therefore it means x also is equal to 2. So the answer here is x is equal to 2. How do you go about it? You can prove and say log base, remember x is 2, log base 2 of 4 is equal to, then you bring your calculator. Let me punch this with my calculator. Remember, this is an equation, so it must work. I've got my log there with a base. In this case it's base 2, and then I punch a 4. I must get a 2. So you can see that the answer gives me a 2, which means my x is correct. So another way you could have done it, as I was saying, you can do it in two different ways. Remember, this is same as x squared is equal to 4. You can square root both sides and say square root of x squared is equal to square root of 4. So what is x? X is equal to 2. Why am I saying square root? Remember, x to the power 2 is equal to 4. You can literally say, let me multiply here by power 1 over 2. You also multiply here by power 1 over 2. So the 2 will cancel to give you now an x is equal to, now x to the power 1 over 2 is same as square root of 4. or you can say 2 to the power 2 into 1 over 2. Whatever way, that will cancel and the final answer will give you x is equal to 2. So this is how you can solve that. Now let us move on again to look at the next question, whereby you can also solve for x using the logarithm equations and also using these laws of logarithms. So what are we given here? We are given log in base 5 of 25 is equal to 3 log in base x of 36 minus log base 3 of 27, and you're supposed to solve for x. One thing that I always say with the logarithm equations is they might look a bit complicated, but in actual fact, if you can look at the pattern, the way they bring these questions, you can actually get all of them correct always. Look at the first one. Now let's simplify individually. Let's first start by looking at this log 525. So you can see, if I can look at log 5 of 25, it's not difficult. You can see that 5, remember, is 5 squared, so you've got log in base 5 of 5 squared. And remember, there is a law which says if you are given log in base a, x to the power n is equal to, the n must drop. You must check that law. The n must drop so that you get n log a to the power x. So the same thing here, in the 5, the 2 will have to drop so that you are going to have 2 log base 5 of 5. That's simple what you are given there. Now also remember the law which says log in base a of a, if the number and the base are the same, you get a 1. So in this case, you're going to have 2 into a 1. So in other ways, this is a 2. So log 525 is a 2. Similarly, you can play around log 3 and 27. Now, if you play around log 3 and 27, let me do it this size, log 3 of 27. If you look at this one, again, it's similar to the log 5 of 25 in this case. What is 27? 27, if I can take my calculator, and you see 27, I think is 3 to the power of 3. If you say 3 to the power of 3, what you get? You get 27. So similarly, this is same as log in base 3 of 3 to the power of 3. Remember, the 3 will drop, similar to what we did here on the 2. So the 3 will drop so that you've got 3 log base 3 of 3. Similarly, we had got 2 log 5 of 5. In actual fact, here it means we also have got 3 times 1, which is our 3. So you can see that this expression on its own is actually much simpler. So where there was log 525, now you can see now that we have got 2 is equal to 3 log base x 36 minus 3. Are you seeing that? If I can just clear up, because you saw how all this happened, I can clear up now so that I can have a clean board. So now if we can continue with that, you can take 3 to the other side. Remember, 3 is negative. If it jumps the equal sign, it will become positive. So now you are going to have a 2 plus 3 is equal to 3 log base x of 36. I hope you're following. So now what is it? 3 plus 2 is a 5. So 5 is equal to 3 log base x of 36. Now from here, what you need to remember is you want to use this law of logarithm. If I can write that law, remember I said if you are given log, for example, log in base of a of x is equal to b, Now you want to use the logarithm equation. You are going to say x, which is that x, is equal to a, which is a base here. Also, it will be a base in exponents. So you want to use that particular law. But the challenge here is you are having that 3. So you need to first to divide everything. You must divide it by a 3. Even here, everything you divide it by a 3. So if you divide everything by a 3, what you're going to have is 5 over 3 is now equal to log base x of 36. I hope it is clear. Now let me just have a ruler here so that we can divide our space, so that we can continue on the other side. Now I want to rewrite it and say, therefore, this is the same as saying log base x of 36 is equal to 5 over 3. I'm just rearranging what I'm given here. Now using this law that we mentioned here to say the x here, you can see is 36. So I'll write 36 is equal to the a here, the base, it was base a, in this case is base x. So I'll have x to the power 5 over 3. So that's how I have got that. Now the next thing that I need to do, remember, is to find x. So whenever you're given that, if you can revisit the examples on the laws of exponents, if you are given log 5 over, log to the power 5 over 3, the first thing that you must do, or to get rid of that 5 over 3 is an exponent, you must multiply by 3 over 5. You see, why are we doing? So that the 5 cancels the 5 and the 3 cancels the 3. But it is not proper for us to do one thing on the right hand side. Remember, what you do on the right hand side, you have to do on the left hand side. So in this case, it's the same thing. You have got 36. Now you have to multiply by what we introduced in red, which is 3 over 5. So now in this case, this side you'll have your x. You are allowed to take your calculator here, and because they didn't specify that don't use a calculator, you can take your calculator literally and punch 36 to the power 3 over 5. So you will have, can put in brackets, 36 to the power, you put in fraction, and then it says 3 over 5. And you can see actually it's giving us 8.5858. It can be the answer in this case. If they say to 3 decimal places, you can see that is 8.585. This 8 will change to become the 6, so 8.586. So you're going to say 8.586 into 3 decimal places. So that is how you can solve a problem like this. So the value of x now is equal to 8.536. So using this method, you can say that it is much simpler for you to solve the problems involving the laws of logarithms. Now I'll encourage you to practice similar problems so that you can have a better understanding of these. We've come to the end of our lesson. See you again in more practice involving the laws of logarithms. Thank you.
I reached out for my dreams, I reached out for my vision, I reached out for help that I thought I needed. 'Cause reaching out is the proof of